Welcome back to particle physics. So last time I made a promise that today we would talk about the hadrons. What are the hadrons? I hear you ask. Last time you said we were going to talk about baryons and mesons. Well, the hadrons are a catch-all term for material that is made from quarks. Hadrons come in two distinct groups called baryons and mesons, and they're both made from quarks. Baryons are formed by a quark triplet, so QQQ, three quarks in a combination, and the proton and the neutron we've already seen are examples of a quark triplet, so they must be baryons. So any particle made of three quarks is an example of a baryon, and a baryon comes under the heading of being a hadron. Mesons, on the other hand, are formed by quark-antiquark pair combination. So a quark going together with an antiquark forms what we call a meson. And the pi is the simplest example of a meson, since it consists of combinations of up and down quarks and antiquarks. The pi minus consists of a down and anti-up quark, and if you reverse the quarks to up and anti-down, you get the pi plus particle. And there are two ways to form a neutral pion. So hadrons contain subgroups called baryons and mesons, and the hadrons that are baryons are formed as QQQ. So triplets forming the proton and the neutron of QQQ, three quarks. We also have these quark-antiquark pairs that we call mesons. And so a quark and an antiquark can give you these various types of particles. So it's worth noting that there are lots of other hadrons. We have other examples of hadrons where they would combine in the kind of QQQ way, and we have lots of other combinations that would form quark-antiquark pairs. So we can have lots of baryons and lots of mesons by combining different quarks. Now while we're here, we might as well talk about baryon numbers, because baryons have a baryon number of 1. Now if a quark is a third of a baryon, then it has a baryon number of a third. Now an antiquark will have to have a baryon number of minus 1/3, and that has a consequence for the mesons, because they're always quark and antiquark combined. So their baryon number will always be 0, because they always have a plus third belonging to their quark and a minus third belonging to their antiquark. So that really means that all mesons will have a baryon number of 0. And so it's important to recognize that that will be the case, because later you'll be looking at conservation equations where you're conserving charge and baryon number and lepton number, and it's worth noting then that all of these mesons have a baryon number of 0, because their quark baryon number cancels out with their antiquark baryon number. Okay. So hopefully now you've got a little bit of an idea of the particles that we can identify as being baryons, and others that we can identify as being mesons. I know particle physics has its ups and downs, and it can at times seem quite strange, but you don't need to wear a special charm to get to the bottom of it, and hopefully at some point you'll rise to the top. Thanks for watching.